The universe is vast. It's filled with billions upon billions of stars, and around many of those stars we now know are planets. Some of these planets are similar in size to Earth. Some orbit their stars in the habitable zone where temperatures might allow liquid water to exist. This raises a profound question: are any of these distant worlds home to life? And if so, how common is life in the cosmos? A new mission concept called LIFE, or Large Interferometer for Exoplanets, aims to help us answer these fundamental questions. The LIFE mission has a singular ambitious goal: to search for signs of life on planets beyond our solar system. These planets are called exoplanets. We can't yet travel to exoplanets. They're just too far away, but we can study their atmospheres from afar. The LIFE mission plans to do just that. By analyzing the light that passes through an exoplanet's atmosphere, LIFE will look for telltale chemical signatures of life known as biosignatures. LIFE is not just one telescope. It's a fleet of 4 telescopes working together. These telescopes will fly in a precise formation, millions of kilometers apart. They will act as a single, giant telescope, with incredible resolving power. This formation will be carefully positioned in space, far from the blinding light of our sun. At the heart of the formation will be a central combiner spacecraft. This spacecraft will combine the light collected by the 4 telescopes. One of the biggest challenges in observing exoplanets is that they are incredibly faint compared to their host stars. It's like trying to spot a firefly next to a spotlight. To overcome this challenge, LIFE will use a technique called nulling interferometry. This technique works by combining the light waves from the 4 telescopes in a very specific way. The light from the star is cancelled out, while the light from the planet is amplified. This allows us to clearly see the faint light from the exoplanet. Mid-infrared spectroscopy, unveiling the secrets of atmospheres. In this section we delve into the fascinating world of mid-infrared spectroscopy, a powerful tool that allows us to peer into the atmospheres of distant exoplanets and uncover their secrets. Once we can see the light from an exoplanet, we need to analyze it to understand what it's made of. This light carries a wealth of information about the planet's atmosphere, including the types of molecules present and their concentrations. This is where spectroscopy comes in. By breaking down the light into its component wavelengths, we can identify the unique signatures of different molecules. Each molecule absorbs light at specific wavelengths, creating a distinct pattern that we can detect and analyze. Spectroscopy is like taking a fingerprint of light. Just as every person has a unique fingerprint, every molecule has a unique spectral signature. By comparing the observed spectra with known signatures, we can determine the composition of the exoplanet's atmosphere. It allows us to identify the different molecules that are present in an exoplanet's atmosphere. This information is crucial for understanding the planet's potential to support life and its overall habitability. LIFE will focus on the mid-infrared part of the light spectrum. This range is particularly important because it contains the signatures of many molecules that are key indicators of biological activity. This is because many molecules that are indicative of life, such as water vapor, are most easily detected in the mid-infrared range. Water vapor is a critical component of any atmosphere that could support life as we know it. Methane, another important molecule, is often produced by biological processes. Detecting methane in an exoplanet's atmosphere could be a strong indicator of microbial life or other biological activity. Ozone, which forms from oxygen molecules, is another key molecule with strong signatures in this wavelength range. The presence of ozone could indicate an atmosphere with significant amounts of oxygen, which is essential for complex life forms. By studying these molecules and their interactions, we can gain a deeper understanding of the potential for life on distant worlds. The numbers game estimating habitable worlds. Finding even a single inhabited world would be a momentous discovery. Imagine the implications for science, philosophy, and our understanding of our place in the cosmos. It would be a revelation that could change the course of human history, providing answers to questions that have puzzled humanity for centuries. Are we alone in the universe? Is life a rare phenomenon, or is it a common occurrence across the vast expanse of space? But LIFE's observations could also tell us something even more profound: how common are inhabited worlds in the universe? By studying the stars and the planets that orbit them, we can begin to understand the frequency of life-bearing worlds. This knowledge could help us grasp the conditions necessary for life and the likelihood of its emergence elsewhere. The Milky Way alone contains billions of stars, each potentially hosting planets that could harbor life. By observing a large number of exoplanets, life can help us estimate the fraction of Earth-like planets that actually support life. These observations will provide critical data on the atmospheres, climates, and potential biosignatures of these distant worlds. Understanding the diversity of exoplanets and their potential to support life will be a significant step forward in our quest to find extraterrestrial life. If life finds biosignatures on many of the planets it observes, it would suggest that life is relatively common in the universe. This would mean that the conditions for life are not unique to Earth, and that the universe is teeming with life in various forms. Such a discovery would have profound implications for our understanding of biology, evolution, and the potential for intelligent civilizations beyond our own. But if life searches dozens of potentially habitable worlds and finds no signs of life, it would suggest that life is perhaps much rarer than we think. This would raise new questions about the uniqueness of Earth and the factors that make our planet so special. It would also prompt us to reconsider our strategies for searching for life and to explore new avenues of research in astrobiology. Either outcome, whether we find life or not, will provide invaluable insights into the nature of life in the universe and our place within it. Beyond detection, understanding the conditions for life. Even if life doesn't find definitive evidence of life, its observations will still be incredibly valuable. By studying the atmospheres of a wide range of exoplanets, life will help us understand the diversity of planetary environments in the galaxy. It will tell us how common or rare different types of atmospheres are. It will help us learn more about the conditions that are necessary for life to arise and evolve. The uncertain path forward. The life mission is still in the concept stage. It faces many technological and financial hurdles. Building such a complex and ambitious space telescope array will require significant investment and international collaboration. But the potential scientific return is enormous. Life has the power to revolutionize our understanding of life in the universe. A new perspective on our place in the cosmos. The search for life beyond Earth is one of the most profound scientific endeavors of our time. For centuries, humanity has gazed up at the stars, wondering if we are alone in this vast universe. The quest to find extraterrestrial life is not just about answering a scientific question, it is about understanding our place in the cosmos. This search has driven scientists to develop new technologies, build powerful telescopes, and embark on ambitious space missions. Each discovery, each piece of data brings us one step closer to answering the age-old question, are we alone? The LIFE mission, if realized, would be a giant leap forward in this search. LIFE, which stands for Life Investigation for Exoplanets, aims to explore distant planets that may harbor conditions suitable for life. This mission involves sending advanced probes and telescopes into space to gather data on exoplanets' atmospheres, surfaces, and potential biosignatures. The information collected could revolutionize our understanding of where and how life might exist beyond Earth. The mission's success would not only be a scientific triumph, but also a testament to human curiosity and ingenuity. It has the potential to answer one of humanity's oldest questions. Are we alone? The implications of finding extraterrestrial life are profound. It would challenge our understanding of biology, evolution, and the uniqueness of life on Earth. It would also raise new philosophical and ethical questions about our place in the universe and our responsibilities as stewards of our planet. Even the mere possibility of life elsewhere can inspire awe and wonder, reminding us of the boundless mysteries that await our exploration. But even if life finds no signs of other life, it will still provide us with a new perspective on our place in the cosmos. The data collected will enhance our understanding of planetary systems, the formation of stars and galaxies, and the conditions that make a planet habitable. This knowledge will deepen our appreciation of Earth's uniqueness and the delicate balance that sustains life here. It will also inform future missions and guide our search for life in other parts of the universe. It will remind us that we are part of something much larger than ourselves. The universe is vast, and our planet is just a tiny speck in the grand cosmic tapestry. This perspective can foster a sense of humility and interconnectedness, encouraging us to cherish and protect our home planet. It can also inspire a sense of unity among humanity, as we realize that we are all part of the same cosmic journey, sharing the same hopes and dreams for the future. and it will inspire us to keep exploring the universe and unraveling its mysteries. The quest for knowledge is a fundamental part of what it means to be human. As we push the boundaries of our understanding, we open new doors to discovery and innovation. The search for life beyond Earth is not just about finding other beings. It is about expanding our horizons, challenging our assumptions, and embracing the unknown. It is a journey that will continue to captivate and inspire generations to come. Thank you for viewing. We look forward to your participation in our next video. Please like and subscribe to our channel.